Hi, my name is Jose Ish. I have a master's in education and I'm a maths teacher. In this video, I'll be sharing with you how to find the volume of a pyramid. A pyramid is quite an interesting shape because it's a three-dimensional shape. That means it's a shape that you can manipulate with. It's a solid actually. You can manipulate and touch. Very different from a 2D shape that is, for example, a picture on the wall. Now, pyramids are quite important because if you look at ancient history, ancient civilization, we find that many pyramids were built in Egypt, and we've got the biggest pyramid in the world, which is the Pyramid of Giza, and it's still quite one of the world 7 wonders of the ancient civilization. So it's quite an interesting topic to actually delve into. Now, this is a topic within the area of mensuration, and mensuration pretty much has to do with a lot of shapes. So let's move on to how to find the volume. Now the first step is we have a formula already that is here on the board that is 1/3 times base area times perpendicular height. Now for the purpose of this video, we're not going to delve into how to work out the formula, where the formula comes from. We pretty much is going to assume that this is the formula and then work with this formula, not really finding out how come the formula looks like this. That's another lesson for a different topic. Now, the first thing to do is identifying, first of all, your pyramid. I've got a pyramid here, which I just made. Now, if you can see, over here, the base is this side, okay? And if you can see, this is the height from this bottom up to the top. So that's what determines the height of the pyramid. Now, this pyramid is the one that is on the board. So by looking here, we already have the form of a rectangle. That's the base that we have. So the first step is to plug in the values in the formula. So we have 1/3 times the base area. We can quickly find out this base area because we have the area of a rectangle equals L times W. Now your L is your length and your width, or W is your width, which is in this case 3. So what we can do, we can multiply 7 centimeters times 3 centimeters. Now what we can do is multiply the whole number 7 to the whole number 3, which gives us 21. And these are variables here, so we have centimeters and centimeters. Now we need to multiply that, and according to algebraic rules of exponent and multiplication, if we have centimeters times centimeters, we are assuming, or we know that there's an exponent here of 1 in each of these variables. So because the base centimeters and centimeters is the same, we can just add the exponents. So 1 plus 1, which is 2. So this gives us centimeters squared in this case, and that's the value of the area of this rectangle. The next step, after we found this area, we can plug it into the original formula. So we can say that we have, in this case, 1/3 times 21 centimeters squared, and then times perpendicular height. Now the perpendicular height is already given here, which is 5 centimeters. So we're going to do times, in this case, 5 centimeters. Now, the thing to do is, when we have found all the values as given here, we can just multiply each of them. Now the volume, in this case, we can write volume again here, okay, abbreviation of V. We can say the volume here will be 1/3 times, now we're going to multiply 21, in this case, with, instead of multiplying 21 and the 5 centimeters that is here, let's start off first with this part. So we can do 1/3 times 21, like this. And the first thing to do is, because we have here a fraction and we've got a whole number, we need to assume, or pretty much in mathematical terms, any number can be described as a fractional number. If we've got 21, it's the same as having 21 apples, which you are dividing into one child. And then if you've got 21 apples divided to one child and given to one child, it's just 21. So writing 21 and 21 over 1 is the same thing. So we can write here over 1. So when we do that, we're going to have this, now we have here centimeters squared times 5 centimeters. Okay? Continuing, we have volume equals, over here, because we have a multiplication of fractions, we can multiply 1 times 21, which is just 21. 21. And 3 times 1, it's 3. So we have 21 over 3. Then we have our centimeters squared here times 5 centimeters. Now the next step is to then divide. You can divide 21 over 3, which in this case is 7 centimeters squared times 5 centimeters. Now here, what we can do, the next step is to multiply the whole number. So we have 7 times 5, which gives us 35. And then we have centimeters squared in centimeters. So that's as I've alluded earlier. So if we have here centimeters squared times centimeters, pretty much the rules of algebra tells us that any number or any variable has an exponent of 1. So we know that there's an exponent here of 1. And because the base cm, which is in this case centimeters, this one, and this base, they are the same, all we need to do is to add the exponent. So we're going to add 2 plus 1. In this case, we're going to have here centimeters to the power of 3, or cubed. So our final answer is 35 centimeters cubed. And that's the final answer. So that's the volume of this first shape. Now we're going to move on to the second shape. Okay? Now this is again another, in this case, pyramid. Now we're going to find the volume of that pyramid.